We use chain rule of differentiation for the derivative of composite functions. Okay, there's an investigation here in your book that you could use, but we don't have time to start going through that. But for your own, maybe self-study or whatever, you're welcome to do that. So for example, if y is a function of g and g is a function of x, what do I mean by that? Look, this gf of x means g is a function of this and f is a function of this. Oh, no. This function is the composite of these two functions. Is that not? So how do we differentiate a composite function? Let's do some experiment on the board. Then I introduce the chain rule technique of differentiating to you. Let's pick two simple functions. For my margin, my OCD margin, my dates. Chain rule is used for derivative of function of function. The chain rule of differentiation is used to find the derivative of function of another function. That is, if y is a function of u, can you see that? Y is expressed in terms of u, okay? But u itself is in terms of x. How do we find dy by dx? This is where chain rule helps. You can see, if we could find easily dy du, do you agree with me? Okay, y is a function of u. Who agrees we could find dy du easily? Hello? Then from u in terms of x, you can find du dx. Du dx means differentiate u with respect to x. Of course, this is possible because u is in terms of x, right? And also because y is in terms of u, you can easily find dy du. That's also possible. But we're not interested in that. We're actually interested in dy by dx because y is now a composite function eventually. So let's take two simple functions and put them in composite form. Still not working, I'll watch the video later. Okay, bye. So let's pick two functions. Let y be, say, u squared. And let u be x minus 2. Can you see this? So if I call this, let's say f of u or whatever, it doesn't matter. Okay, so from here now, y is definitely x minus 2 squared. Do you agree? Which means y is x squared minus 4x plus 4. Okay, which means I can now find my dy dx to be 2x minus 4. Agree? Which is simply 2x minus 2. This same problem is this. F of x is equal to x squared. And g of x is equal to x minus 2. Okay? Then let's see g composed with f of x. No, it's the other way around. F composed with G. F composed with G of X will be F of G of X, right? Which is simply F of X minus 2, which is simply X minus 2 squared. So let this be our Y. Okay, and clearly your dy dx is going to be the way we did it above. Understand? Remember, this is x squared minus 4x plus 4. Then it's going to be 2x minus 4, which is 2 bracket x minus 2. So you can see that this is the derivative of composite function. However, we don't have to find the composite all the time. We don't have to find them as, combine the composite and, expand it and all that. We don't have to do that. Chain rule can actually allow us to do it. We will try to suggest what has been used to compose what. For example, somebody says, find the derivative when y is equal to x minus 2 squared. We don't have to, try to expand. We can extract it, and say, oh, let the inner one be x minus 2 so that I can write my y as u squared. With the chain rule of differentiation, we will find our du dx, which means differentiate u with respect to x, and that gives 1. Do you agree? Okay, this is normal rule of differentiation. So that's how chain rule is done. So for chain rule of differentiation, we will use simple rules of differentiation for each of them. Du dx is equal to 1. Here you can find dy d what? Dy d what? Talk to me.
Du.
Du. Here we can find dy du. And that would be what?
2u.
2u. You are treating it just like you have x squared. If you have x squared, what is your dy dx? Isn't that just 2x? Okay, so again, this is dy du. It means with respect to u. So instead of x, you are dealing with u now. It's the same thing. Does that make sense, guys? So here we will find dy du to be 2u. By chain rule of differentiation, look at this. Look at what I'm going to write now. Dy dx is actually just dy du times du dx, such that it looks like a fraction where this can be cancelled. Can you see that? Whatever I differentiate with in the first one will be the main variable in the second one. Okay? Here, the independent variable is u. The dependent variable is y. In the other one, u is now the independent variable, x is the dependent variable. So my independent variable in the first one is my dependent variable in the first one is my independent variable. No. I think it's the other way around. If you have y equals x plus 3, y depends on x. Understand? If you put x is equal to 5, then you can get y to be 8. Do you understand what I mean? So in this case, my y is the dependent variable. This is dependent variable. And this is my independent variable. Do you understand? Independent means it doesn't, like x is equal to 5, I can choose any value. It doesn't depend on y to choose that. But my y equals to 8 depends on that x is equal to 5. Okay? So that is why we call y the dependent variable and this as independent variable. So my independent variable here becomes my dependent variable here. That's the point I'm trying to make. Understood? So with this in mind, we can write, this is how we do our chain rule. We're going to do it properly now. dy du is 2u. Du dx is 1. And this is simply just 2u. Then we substitute back, because it is dy dx, so your result should be in terms of x. Then you substitute back x minus 2, which is exactly what we got here. Okay, so chain rule is that simple. You look at it, it's definitely the result of a composition. Then you try to break it into the two simple functions that made up that composition. Do you understand? Once you're able to get each of them, find the derivative of the individual functions, then make sure you put them properly in a way that when you multiply the two, it looks as if you are simplifying a fraction that end up giving you dy dx. Then you do that product. You don't need to expand. Just simplify your results, introduce your x back, and that is the end of the chain rule. Any questions? So chain rule is very short and simple. So let's do some examples. I'm going to write it. Chain rule. Of course, I've written chain rule a lot of times, so you don't need to write chain rule again. If y is a function of u, and u is a function of x, then this is the chain rule of differentiation. Dy by dx is simply dy du times du dx. dy du dx. This is the chain rule of differentiation. So we're going to take some examples now. Y equals 2x minus 5 to power 10. Check this out, everyone. It's easy to do power 2, right? Because you can easily expand and factorize your result like we did in this one. But what happens when the power is 20 or even 2000? Are you going to expand using binomial, differentiate all the terms and factorize back? No, that's why chain rule comes in. Okay, so this is how you go about it. You start by saying, you can see that this is that function, one of the functions that was composed together. Understand what I mean? Let the inner one be u. Then the y will now be written as u to power 10. Can you see this? So always write that. From here, you find the u dx. And from here, you can find the y du. The u dx is simply 2. Is it okay to write 2? Does everybody understand why it is 2? I can't see everybody's face. Let's scroll down. Is it okay to write 2? Callista?
Wait, can you explain why it's 2?
What?
Can you explain why it's 2?
I can't hear that, please.
Can you explain why it's 2?
That's 2 times 1. Derivative of x. This is a constant. 1 x 1 minus 0. The minus 0. The derivative of 2x, you use constant times f of x. And that will be constant times derivative of f of x, right?
Oh, okay.
And the derivative of x is 1. Understand? So I think what I'm going to write is 2 brackets 1, so I don't go too fast. Something like this. 2, 1 minus 0. Is this better?
Yeah, thanks.
Good. So, and this will be 2. So please feel free to write that. Why the derivative of this? Clarissa, can you tell me the dy du? I'm going to be calling you in this section. Clarissa, what is dy du?
10u with the power of 9.
Perfect. 10u to power of 9. Then you recall your chain rule, okay? So you just write after that, dy dx, always write the chain rule, always, please. It's simply dy du times du dx. Then substitute exactly the way you write it in that order. Dy du is 10u to power 9. Du dx is 2. I didn't bring my 2 first. Please just be consistent. And this is 20 u to power 9. Then we substitute 20 brackets 2x minus 5 to power 9. And that's it. Understood? I want everybody to try this. Attempt this activity. I'll put 3 questions. Attempt these 3 problems. Send to my WeChat, one after the other. I'll pause the recording now.
Power. We now find the derivative of u with respect to x. We do this term by term. For each term, we multiply the constant coefficient by the power and subtract 1 from the power. dy by du must be multiplied by all of du by dx. Since du by dx has 2 terms, it is essential to write this derivative in brackets. Finally, we replace u by its quadratic expression in x. This makes sure our answer only involves the one variable. Now consider the function in part b. How can we write it as a composite of 2 simpler functions that we know how to differentiate? We can see there is a linear expression under the square root, so we let this linear expression be u. Y is 4 over the square root of u, which is 4 times u to the minus 1/2. We know how to differentiate both of these functions, so we can use the chain rule. To find the derivative of y with respect to u, we multiply the constant coefficient by the power and subtract 1 from the power. We now find the derivative of u with respect to x. We do this term by term. The derivative of the constant 1 is 0, and the derivative of minus 2x is minus 2. We expand the brackets, taking care with signs. Finally, we replace u by its expression in x. With practice, you should be able to apply the chain rule without having to write down expressions involving u at all. For example, look again at the function in part A. It is 1 times an expression in brackets to the power 4. The derivative dy by dx is the coefficient 1 times the power times the expression in brackets. We subtract 1 from the power, then multiply by the derivative of the expression in the brackets. Now look at part B. Can you apply the same thinking? It is 4 times an expression in brackets to the power minus 1/2. The derivative dy by dx is the coefficient 4 times the power, times the expression in brackets. We subtract 1 from the power, then multiply by the derivative of the expression in brackets. This simplifies to our answer.
Now, the thing with this shortcut is that you will have to learn it. But for now, I want you to only worry about applying the y du, and I want you to follow the same order. That's not the order used in the example that I just played for you. I want you to follow the same order that you've been following in your practice now. That's easier for a beginner, okay? So when you see a function that is a composition of 2 functions, pick the simple function you can see anywhere, pick it as a u, okay? And write the orders as, y in terms of u, something like that. Differentiate each of them under the let statement, then apply chain rule and simplify back. Just stick to that. Okay. Then when we are doing the product rule, maybe today, maybe when we meet in school tomorrow, we will not apply chain rule in details. We will use the shortcuts. So the question is this: when do we use shortcut officially, and when do we not need to use shortcut officially? So listen. In chain rule of differentiation, let me try to show you something. In product rule, sorry. In product rule of differentiation, you might be dealing with something like this. Are you with me? Something like this, for example. This is chain rule. To differentiate this is chain rule, right? But because this is a product rule problem, you don't need to go into details of let u be x squared plus a, then y will be. This is not y. Everything here is now y. So in that case, you have to use shortcuts. I will tell you more when we get to that point. Okay, for example, this one could have been done by chain rule. But because the question appears in product rule, there's no need to use chain rule multiple times. Okay, so for now, let's just stick to the process that we've been using. I want you to try. Okay, I want you to try this problem. E and F, 4E and 4F. 4E and 4F. So try that as maybe question 4 and 5 or something. The next two questions in your exercise. 4E and F. Maybe I take the screenshot and send to the group just in case. Write your 4E, find the gradient of the tangent to, of course, you know that means find dy dx. So I'll take some screenshots of some notes if you want later. We don't need to start from here. This is just finding composition. You've done composition before. We don't need this investigation. You can have a look at it. So I'll just take a screenshot from here. Chat. I hope you've all copied the question. Speak up if you haven't written the question, so you don't have to waste too much time. All right, 4E and F, all the screenshots are now on the group. Oh, Clarissa, I just saw the correction you sent. So it's good now. Thanks. Okay, Mr. Chang, simplify properly. And each time you write question, can you put the question first? You just say, let U be this, why is equal to this? How do I know if you've put the right let U? I need to be able to check with the original question. So it won't be a bad idea if you write y is equal to something, which is the original question first, please. So in about 5 to 7 minutes, I will stop you. I will introduce product rule briefly, then we call it a day and practice that in class tomorrow, and we move to quotient rule. So if we can do like half, then by the end of tomorrow's class is just a single period. So I want us to forget about product quotient and everything tomorrow. So when we meet on Thursday, we will go to, what is the next thing on my plan? Exponential function and logarithmic function. I hope it's a double period. Okay, Thursday is a single period. Okay, no problem. Thursday only will probably be exponential. I don't think rush to logarithmic. Then Friday, which is double, we can do logarithmic function and trigonometric function since we have a double lesson. Then when we meet by weekend, hopefully we have time to meet. We can do the school. Yeah. Unless we can do 11 to 12. I think school begins at 1 for me. We can do 11 to 12. We can do arc inverse trig function. Okay, some entries are in. So let's use that. Good question. Okay, thanks for putting the question. So, okay. Mr. Cheng, so you don't need to put that times because there's a bracket already. Okay? Okay, good. Yeah, that makes sense. Let's see any other one. Clarissa took it back. Too bad. She sent me a message. She took it back. Thank you. So I can check here. Two instances. Existence of limits. Today. Calista checking. Let's see. Calista, let u be 4x. Where does that come from? You cannot open the bracket. There's a -1 as the power. Understood? So this your let is actually not the right way to go about it. Okay, so somebody got 3/8. Somebody's getting 3/32. Now I don't know what to believe anymore. Let's see, between 18 and Nikita, who should I trust? I don't trust any of them. Calista, your u should just be x plus 2 root x. So that your y will be 4/u. Calista? Understand?
Yes.
So from the beginning, you don't have to do any simplification. Just pick u equals the denominator, because there's a function at denominator. Then your y will be 4/u, which is 4u to the power -1. That makes life easier. At x equals 4. Yes, 4 plus 4, 8 to the power -2. 4, 8 to the power -2. 1 plus 4 is to the power, that is 3/2. 4 to the power -half is 1/2. Then there's 3/2. Ethan Chang, I think you should check your work. If your result is not -3/32, it might be wrong.
Yeah, I'm checking that one right now.
Have you seen it?
Yeah, because I looked at the answer and it was wrong, so I'm just going over my work now.
Okay, so I'm going to check also for you. Oh, your 8 squared is not 16, it's 64, bro. Yeah, you didn't get enough sleep. You didn't get enough sleep. All right, so fix that. Then I'm checking your work. Then I got 3/4. So let's try to figure out together, Miss V. Oh, I see. Your u squared, Venna, in the last step of dy dx before at x equals 4. You forgot the square on u. Where is she? Can you see it? You forgot the square on u. That's why. Yeah, you did something wrong. Did you hear that? You get the correction?
I'm fixing it right now.
Okay, perfect. Clary, check in. 3/32. Yeah, that's correct. Clarissa, you don't have to write -12/128. You know why? What if question like this is given in paper 1 where calculator is not allowed? So using big numbers, the only message it sends to me is that you are relying on calculator. Okay? That's why hello, Clarissa, did you hear me?
Yeah.
That's why you should know how to cancel in fraction. So from your -4/1/8 squared, you can write -4 times 1/64 times 3/2, and you can do the cancellation and get 3/32 negative. So although your answer is correct, but it shows that you probably just use calculator to fix that. So you need to try to avoid simple ones. Unless you're in a hurry, like we're doing practice in class, I want it fast, then yes. Otherwise, let your work show that you're not relying on calculator too much. I love this. My plan for calculus, I put it as topic 1, and we are already in 13, so we're going to finish 14 now, and we still have the whole of November and even December. No, for differential calculus. Okay, so maybe I shouldn't be too happy yet. We still have integral calculus as well, so should be all right. We're not doing bad. Should be all right. Okay, 12:34. I'm gonna stop you in. Let's see. Okay, I've seen F. Is 0? Okay, let's see. That's 1. Yes. Cube. Cube. Nice face cap, Mr. Chang. Yeah, you have that. So you put 1. Yeah, that's 0. That's weird. Do you mind putting that on decimals? Let's see the shape of that curve. If that point is a turning point, then you're right. Okay, Nakita, put that curve, number F, in some graphic display calculator or use decimals online. And if that x equals to 1 is a turning point, that explains why your answer is 0. Because the tangent at that point is going to be parallel to the x-axis, and that gradient will be 0 at that point. That's why. We're going to be talking about turning point, dy by dx is equal to 0 at the turning point later. All right, I'm gonna go back to my book. Oh, something else. Miss V fixed it, I guess. Yes, this makes so much sense now. Good. So I'm going to introduce the product rule in the next 4 minutes. We will not practice that today. We'll practice at the beginning of the class. Thank you, Ethan. Did you see? At x equals 1, there is a turning point indeed. Okay, Ethan, send that picture to the group. And click on that dot so that the value is reflected in your screenshot.
Oh, on mobile, it doesn't show, but if you look at the bottom, like at the x-axis, you'll see like a 2 and a 4. And
oh, yeah. So next time you go to, you know that setting symbol, you put x-axis step 1, then it's going to show you 1 next time.
Oh, okay.
All right, thank you. Crystal K got your results and is correct. Correct. All right, so. Okay, more entries. Come on, guys. I want to write on the board. You keep sending stuff. Okay, it's Mr. Chang again. Got it. So everybody, can you send that to the group? Did you send to me or the group? Oh, the group. Got it. Thank you. So that's why the result is 0 at that point. It's a turning point. We'll be talking about that under stationary points later. Start again. Leave me alone, Crystal. Okay, let's check your derivative. Lazy Crystal. You wrote in the second or third line. I'm in E now, 4E, Crystal. Are you with me, Crystal C? In your third line, you wrote the x, the u dx, right? 1 plus 2 times 1 over 2, blah, blah, blah. You didn't show me the final simplified result, but you use it in the calculation. So next time, show that simplified result first before it is used. That's the only thing I can say. Every other thing looks perfect. Perfectly splendid. You guys really need to see that movie. I'm gonna find it and send it to you. Perfectly splendid. Oh, by the way, Nakita, is your sister the Rachel Chu that I saw in a movie last night? Crazy Rich Asians.
No,
I'm like, wait, that should be Nakita's sister.
that's me.
Or some distance cousin. Or maybe you. Who knows?
No, that's me.
All right, product rule, guys. Let's do some introduction to product rules so that we can leave. So the thing is, with product rule, many people might think, it's just going to be the product of their derivatives. No. For example, if you have y equals maybe x cubed, x squared times maybe 2 minus x. So is the derivative, this is derivative of y. That's another notation. Is it going to be 2x times minus 1, which is minus 2x? No. Okay, it's not. So the product rule doesn't mean find the derivative of this and find the derivative of this and multiply. No. Some experiments are in your textbook, is in form of a table. Let me see if I can show you that. If you do not mind, you can actually have a look at those experiments if you have the time, so you can understand product rule better. So look at these functions. Can everybody see the board, the textbook? So look at this function. You can split it into two, right? Derivative of xx is 1, right? But the derivative of the function is 2x. Okay? So if you look at that, maybe we all write on the paper. Let's complete this table somewhere. Let's complete this table. I'm going to complete mine too. Let's take 2 minutes. You have f of x. It doesn't have to be neat. It could be on any strange paper. F prime of x, with what we have done so far, it should be easy. The first one is 2x. For x raised to power 3 over 2, the f dash of x will be 3 over 2 x raised to power half. For x into x plus 1, make sure you open the bracket. The same function is x squared plus x. Find the derivative. For the last one also, x minus 1 bracket 2 minus x squared, you have to expand and simplify first from what we know so far, okay? That gives me 2x, or maybe we can do it on the board together, sorry, if that will help understand. Okay, let's draw a table. I have f of x, and I have f dash of x, and I have u, v, u prime, blah, 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 okay? And I have u of x, I have v of x, I have u dash of x, I have v dash of x, and the last I have uv prime, no, u prime v, which is the same anyway. U prime fx, v of x, then uv prime, yeah. U of x, v see. So the first one, simple function, x squared. The second one is also a simple function. Okay, everyone, let's do this together. Help me so I don't have to open different windows. What is the first function? Quickly. Come on, come on, come on. You don't have it? Okay, don't worry. I send it to the group. 1 minute. Send it to the group so it's easier. Got it? All right, so give me the first function to make it easier for me.
X squared.
X squared. Then what else do we have? Okay, the second function, x 3 over 2. This is x plus 1. This is x minus 1, 2 minus x squared, right? And the column we're given is u for this. This is x, this is x. This is x, this is root x. This is x, this is x plus 1. This is x minus 1. This is 2 minus x squared. That's all we have. Okay, everyone pay attention now. Don't look at your book, just look at the board. For this will be 2x. Do you agree? So for this will be 3 over 2x, 3 over 2 minus 1, which is simply 3 over 2x to the power half, or 3 over 2 root x. Agree? For this, the first thing you need to do is to expand the bracket. So this is going to be x squared plus x. Then you can find the derivative, 2x plus 1. For this also, we need to expand the bracket. We have 2x minus x cubed minus 2, then plus x squared. So I arrange in order. Minus x cubed plus x squared plus 2x minus 2. So the derivative will be what together? Come on, guys. Yes.
Negative 3.
Negative 3.
X squared.
Mm-hmm.
Plus 2x.
Mm-hmm.
Plus 2.
Then minus 0, which you don't need to write. Yes? Now, let's look at, this f dash of x is from here, because this is f of x. Can we get that? Now, from u, we can find this. So what is this first one?
1,
Second one?
1.
The third one?
Wait. Yeah. 1,
The fourth one?
1.
Okay, I need more response from people, please. From here, we can find this. So what's the first one?
1.
Second, this will be x to the power half first. Then we have half x to the power half minus 1, right? Write that properly. Still doesn't look like 2, sorry. finally. Yes, which I can rewrite as maybe 1 over 2 root something something if I wish. I don't have to. The next is 1. This is 0 minus 2x, which is negative 2x. Is that clear? Now, the last column is from these 3 columns. Give the last one. It means this derivative times this, right? No. This times this, then this times this. Everybody acknowledge if you understand. Okay. So this times this is x. This times that is x. That gives 2x. Again, this times this is root x, right? Then this times this is x over, is it x over 2 root x? Talk to me, yes? Talking about this one now. We can simplify. So if I want 2 root x here, and also 2 root x here, then this will have been root x times 2 root x. So that the first part is 2x over plus x, actually, everything over 2 root x. Please say something if you understand. So I'm going to be having 3x over 2 root x. So I have 3 over 2, then x times x to power negative half. Can you see that? And this is x to power 1. So that gives me 3 over 2 x to power half itself. This times this again, x plus 1, then plus x, and that gives me 2x plus 1. And the last but not the least, this multiplies this and this multiplies that. So I have 2 minus x squared. Then I have that 2, x minus 1 multiplying negative 2x. So 2 minus x squared minus 2x squared plus 2x. So you can see this gives me negative 3x squared plus 2x plus 2. What do you notice here? The purpose of this table is to show that when you are trying to find the derivative of a function that looks like a product, it's not the product of individual functions. So for example, if by the layman's way of reasoning, we would have thought that if your y of x is equal to u times v, or if your f of x is equal to u and v combined, okay, we would have thought that the derivative should be the derivative of u and the derivative of v. Is that not? That's how a layman will have reasoned. But if you look at this table, derivative of this and this is 1 each. 1 times 1 is 1. And that is not the derivative of the function itself. Can you see that? Also, the derivative of these two is 1 and this. So the derivative should have been 1 times this one, which should have been 1 over 2 root something. And that is not 3 over 2 root x. So we can now write the product rule in general. We will apply it in class properly. So product rule. By product rule, of course, we begin from here already. By product rule, or from the investigation, let's write that way. investigation is the table, okay? On investigation, if y is a function of u and v, let me write that properly, because u and v could be numbers. So I'll write this way. If y of x is a product of u of x and v of x, then dy by dx is simply you pick the first one, don't differentiate, you differentiate the second one. Then you swap that order. You can now differentiate the first one and you pick the second one. If you pick this, you differentiate this. If you pick this one, you differentiate that. Something like that. Understood? Some write it this way, some write it the other way. It doesn't matter. No one is wrong. It could be u prime of x, then v of x, then u of x, v prime of x. It doesn't matter which one. Okay? Because it's addition, right? So anyone comes first. It's addition. Any questions? So this is the product rule of differentiation. So I will send some questions to the group. Feel free to practice on your own before we meet in school tomorrow. So just like we did before, maybe on the last notes, we can listen to one example here. Someone needs to leave at 1. If you are strictly going in the next 1 or 2 minutes, I will understand. Just log out, send me a message privately. But this is the last thing I want to do, just in case some people wish to do some practice on their own. All right. And you can watch the last 5 minutes on your own later. Okay. Sorry about that. I just thought I don't want to go into this again tomorrow. Okay. So last example, then I close the meeting.
We have seen the addition rule, which allows us to differentiate term by term. We now consider a rule for differentiating the product of two functions. Our first step is to write the function as the product of simpler functions u and v, which we know how to differentiate. In part A, we let u be root x. We write it as x to the half, so it is ready to differentiate. And we let v be 2x plus 1 all cubed. We find u dashed by multiplying the coefficient 1 by the power 1/2 and subtracting 1 from the power. To find v dashed, we need to use the chain rule. V is 1 times an expression in brackets to the power 3. V dashed is therefore the coefficient 1 times the power times the expression in brackets. We subtract 1 from the power, then multiply by the derivative of the expression in brackets. We can now use the product rule to find dy by dx. We carefully write down u dashed times v plus u times v dashed. Then tidy the expression using more concise algebraic notation. In part B, we let u be x squared and v be x squared minus 2x to the 4. We find u dashed, then to find v dashed, we need to use the chain rule. V is 1 times an expression in brackets to the power 4. V dashed is therefore the coefficient 1 times the power times the expression in brackets. We subtract 1 from the power, then multiply by the derivative of the expression in brackets. Differentiating term by term, the derivative of x squared is 2x, and the derivative of minus 2x is minus 2. We can now use the product rule to find dy by dx. We carefully write down u dashed times v plus u times v dashed. Then tidy the expression using more concise algebraic notation.
So when we come to class tomorrow, I will not be using this u dash notation. Okay, I'll be using v du u dv notation. Precisely
We have seen the addition.
This one. Yeah, this part. And I'll be putting the v first, not the u first. The reason is in quotient rule, V du comes first. So I don't want you to mix them up. Okay, so I want you to already get used to the fact that V comes first when using product or quotient rule. Okay, so what I'm trying to say is this. This is the notation I want you to get used to. Dy dx is simply V du dx plus U dv dx. This is the notation I want you to get used to. Okay, the reason is because in quotient rule, I'm going to write this. V du dx minus U dv dx divided by V squared. Because of minus, you can't just write in any order. V must come first. Okay, but if you are not used to V coming first from here, okay, you might end up mixing it and thinking maybe U will come first because product rule allows you to write anyone either way. Do you understand the idea? So always use this notation to avoid it. So you are already used to that. You are already used to the, should I say, consistency. You know, work with that consistency from now on. You don't have to practice anything tonight. I don't expect that. Practice more on your chain rule. Then we will discuss this. We don't have to go through the investigation. I'll just write the this thing again and we'll take example, maybe the first 15 minutes of the class. I'll teach you shortcuts to chain rule, maybe the first 5 minutes, and then apply it to the product rule, or even introduce the shortcut to chain rule while doing this product rule. We don't have to separate that. We only have 40 to 42 minutes anyway. Then we can go straight to quotient rule and you can practice yourself on Wednesday using the worksheet that I gave you now. Okay, I'll see you guys tomorrow. Thank you for coming. Bye.